We'll go from current slide. All right, ready to go. Before we go, let me give just one major announcement. I meant to give it in my first class, so I forgot. Today and tomorrow, right? There's, what do they call it, activities fair, or what do they call it? I can't remember. Do they have a name for it? Boston State what? Connection Fair, okay. Where I was an undergraduate, we called it activities fair, so I'm used to thinking in those terms. The Connection Fair, and basically what it is lots of campus organizations, I would think most of them, and a few outside organizations that we do things with, like March of Dimes and things like this. Some of the campus organizations do projects for and with March of Dimes. So there will be several of these, and it's today on the Birmingham campus, is that right? 10 to 12, is that right? I thought that's what I heard. And then tomorrow it will be on this campus about the same time. Is that right?
Yes.
Okay.
Yeah, it's from 10 to 12. I meant 10 to 2.
10 to 2 today on Birmingham, is that right?
And 10 to 2 tomorrow.
10 to 2 tomorrow on this campus. Okay. So 10 to 2 on Birmingham. Is it in Leon Kennedy? Or where is it?
Like in the cafeteria and stuff.
Right, okay. Yeah, the Leon Kennedy building on the Birmingham campus in the cafeteria area, right? And then on this campus, it'll be near our cafeteria, so what they call the faculty staff dining room, though I don't know if very many people have ever eaten there, but it's a nice sized room and lots of tables. And so it's 10 till 2 both days. Today on Birmingham, tomorrow on Bessemer, okay? Let's see. Britton's here, Justin's here, Jarian's not here yet. Whitney Taylor's not here yet, right? Elsa Terrell. Jeremy, not here yet. Mike, not here yet. Doc's not here yet. Taiwan, no. Tanisha, Darius, Jawan. And still missing Chelsea, right? Okay. So, any questions on anything we've covered so far? A couple of people asked me for a test. Anyone here who did not get the first test? Okay. All right. And I can tell people are working on it, which is a really good thing to do. There was a question. There were two issues. I wanted to address both of them. Not serious issues, but issues nevertheless. And I think I've given out my last copy of the test, so I hope everybody's gotten it. Okay. And there may be more, so if you have questions, please ask. Okay, number 6 on the test. It says, find the exact values of the 6 trigonometric functions of the real numbers t at the point and standard position. Okay? And what they gave here made no sense. Okay? They gave this point 17/13 and 8/13. You could do it, but the answer in the key in the test bank was wrong, totally wrong, okay? And I saw what they were trying to do. I thought, why would they give you that difficult of a problem? But what they wanted to give you a point on the unit circle. That one's not on the unit circle. How can you tell? 17/13, 8/13, 8/13. 17/13 is greater than 1. How could that be on the unit circle? It can't be. So when I was doing, the key, I used their I thought, I must have typed it wrong. I went back and checked. No, I typed it right. They got it wrong. They told me that the cosine of that thing was 17/13. And when can cosine ever be greater than 1? Never. Okay, so their answer was totally wrong. So I went back and changed it to something not the same but similar. That point, 15/17 and 8/17, I'm pretty sure is on the unit circle, so you can go from there. Okay? So I forgot to cross out the 8/13, so 8/17 is the y value. Okay? Then number 7 there was a question about, and sure, t equal pi fifths is not one of our favorite values for t, but it's a legitimate angle, and I suggested that you use it's on section 4.2, like the second page, that table of definition of your sine and cosine functions. You can get the xy value basically right off of that, not off the table. I mean, it's not in the table, but it tells you how you can get it. If you have more questions about it, I'll be glad to try to specify more. Okay. Any other questions? Let me put this away then. I hope everybody's got a copy because I'm out, but I can make more copies if you need it. So, whoever it was that needed the copy and got it today, Angel was trying to take it from me earlier. But anyway, I beat him off with a stick. So, okay. All right, we're on page. Don't tell me I didn't mark it. Yes, I found it. Okay. We're on page 301, and we had just started talking about amplitude and period. So let me back up. No, we had already done all that. Okay. So if there's no questions, page 301, section 4.5, chapter 4. Okay. The first sentence here on this slide is the third sentence in the paragraph that's just above the definition. The result is that the graph of, let's start with y is equal to a sine x. What does that a do for you? What does what? That's the amplitude. What that does, it either stretches or shrinks vertically. Sine is normally, in fact always, sine is between plus and minus 1. This multiplies a by it. Now if a happens to be a number less than 1, then that's going to be a vertical shrink. If a is a number greater than 1, it's going to be a vertical stretch. Actually, a could be positive or negative, but whatever the function ranges, a sine theta ranges now. See, sine goes between minus 1 and 1. A sine x goes between minus a and a instead of between minus 1 and 1, because you're multiplying a by whatever value minus 1 to 1 and everything in between. So the absolute value of that a, whatever that is, absolute value of a is called the amplitude. A is not the amplitude. Sometimes it is, but it's the absolute value of a is the amplitude. Because a could be negative and amplitudes are always positive. That's what we make them absolute values. So the range of the function is then between negative a and a. Y is equal to negative a and a. Does that make sense? So, amplitude is pretty simple. The amplitude of either function, y is equal to a sine x or y is equal to a cosine x, represents half the distance between the max and min. The max is going to be at plus a, the min at minus a. The difference between them is 2a, and half of that is a. Okay, so it's a weird way to express it, but it's true. But if you have just a set of numbers, and you're not given the function, that's how you determine what the a is. Find the max value, the min value, the difference between those, take half of it. Okay? We will do a problem like that later. It's given by amplitude is absolute value of a. Any questions? Okay. Now, the graph of y is equal to minus f of x is a reflection. So if this is your cosine function, and it's 3 cosine x, so it's vertical stretch from plus 3 to minus 3. If you make it a minus 3 cosine x, then you flip this across the x-axis, and where it was a plus 1 cosine of 0 is 1. So this multiplies by 3, this multiplies by negative 3, and you wind up down there. So the graph of y is equal to f, negative f of x is a reflection in the x-axis of the graph y is equal to f of x. So, like I just said, y is equal to negative 3 cosine x, reflection of the graph y is equal to 3 cosine x. This y is equal to 3 cosine x, you just stretch it from 1 to 3, okay? And then you go to minus 3 down here, a reflection of minus 3 cosine x. You take that 1 multiplied by minus 3, it puts it down here, and now it goes from minus 3 to plus 3. But the pattern then is still the same. Okay, any questions on that? Amplitude, the coefficient, the A, the absolute value of A is the amplitude. The sign tells you whether you flipped across the x-axis or not. Now, because y is equal to A sine x completes one cycle between x equals 0 and 2 pi, because the period for the sine function or the cosine function is 2 pi. It follows that if you did y is equal to A sine bx, you've introduced a coefficient for the x here, what would that be? What does that do for you? Where A is a vertical stretch or shrink, B would be a horizontal. I'm playing the accordion up here. Okay. The horizontal stretch or shrink. But remember, whatever deals with the x is usually backwards from what you do with the y's. So for a small x, you wind up with a stretch. A large x winds up with a shrink. Name, please. Chelsea. Chelsea, I'm sorry. All right. Good deal. My first class this morning, the bottom 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in the alphabet were all here. In this class, the bottom 6 are all here. Top parts of the alphabet having a little more struggle, but the bottom part's doing pretty well today. Okay. So, that to me is how I think of it. How they say it is perfectly fine, but it's a bit bizarre, I think. This y is equal to A sine bx. The A is the amplitude, or as the value rate is the amplitude. The B affects the period. It's not the period, but it affects the period, okay? Because it completes one cycle between x equals 0 to x equals 2 pi over b. Because, this is bizarre, if you put x equal 2 pi over b, the b's cancel out, and then you're going from 0 to 2 pi, which is one period. But to get there, you have to do that. So, where b is a positive real number. Now remember we said a could be positive or negative. We don't let b be positive or negative. We always keep b positive. Okay? So if b is a positive real number, the period of y is equal to a sine bx or y is equal to a cosine bx, a refers to the amplitude. The absolute value of a is the amplitude. B refers to the period, and the period is always 2 pi over b. That's what you remember, 2 pi over b. So when b is large, the period is smaller. When b is small, the period is larger. Okay? Remember, anything dealing with the x is backwards. Okay? So there is your period. That's what you need to remember. So anytime b is between 0 and 1, remember b is always positive, so it can't ever be 0. That would make a lot of sense with it. Okay? If you had y is equal to a sine 0, that's just 0. I mean, yeah, 0. Cosine 0 would be a. So Yeah, we don't let b equal 0. We don't let it go negative. If it's between 0 and 1, then that period is stretched greater than 2 pi and represents the horizontal stretching of the graph. If, however, b is greater than 1, that's a horizontal shrink. Remember, b's are backwards. Okay? Similarly, if b is greater than 1, the period of a y is equal to a sine bx is less than 2 pi, represents a horizontal shrinking of the graph. Y is equal to a sine x. When b is negative, okay, what you do with that is take that minus sign out and put it in front if it's a sine, because sines are odd functions. Okay? If it's cosine, it's the same, because cosine is an even function. So basically, we deal with the minus sign. If b is negative, you deal with that separately, and then keep the bx, use it as if it's positive. Okay? Most of the time, we won't have those. Okay? That's how you deal with the minus sign of the x. The even or oddness deals with it. So here's example 3. What happened to example 2? Okay? They skipped it completely. Okay? Did they? No, we already did 2, didn't we? Or did we? No, we didn't. There's the definition of amplitude. We should have done it right after that. So let me find some clean slide. Let's do example 2 first, and then we'll do example 3. Okay? So let me get my pen set up. Any questions so far? So example 2. They skipped it on the slide set. On the same coordinate plane, sketch the graph of each function. Y is equal to 1/2 cosine x. Okay? The b part will be, this is a part, the b part will be y is equal to 3 cosine x. Okay. So let's do our coordinate plane here. All right. Now, let's get used to plotting trig functions. We're going to be doing it this whole chapter, okay, largely. At least these 2 sections really heavily, okay? Tick off on the x-axis. Now, don't worry about the scales being the same. They're not going to be. The horizontal axis is going to be pieces of a pie, right? Okay? The vertical axis are going to be numbers. So I'm not about to keep them the same. So let's just tick off 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7. Not very even, are they? And here we'll do 1, 2, 3, 1, 2, 3. The reason I did that, the max is going to be 3. I'm going to put half values in here too. Okay? Just for now. Okay. Now, before we begin, what is the parent function of both of these? What's the basic function here? It's a real obvious answer, so don't think it's a trick question. What function are we dealing with? What trig function? Cosine. Okay? So let's first plot cosine. You pick me a color for plotting cosine. Which one? Violet? Is that what you said?
Yellow.
Oh, yellow. Okay, I'll try yellow. Yellow sometimes is hard to see. Sometimes it's hard to get it to come up. But I think that's a good idea. Okay? Let me go back to dark because I needed to plug in my values here. Okay. I meant to say this. what's the period? To determine the horizontal setup here, you need to think in terms of period. What's the period of cosine x? 1 period. Sine and cosine have the same period. What is it? 2 pi. Okay. Now what we do, we take that period and divide by 4. What's 2 pi divided by 4? Pi over 2. So each one of my horizontal tick marks are going to be pi halves. So pi halves, pi, 2 pi, 3 pi, 4 pi. Minus pi halves, minus pi, minus 2 pi, minus 3 pi. I don't have a minus 4 pi. So that's going to be my horizontal scale. Find your period and divide by 4 and mark those off that way. Okay. Vertical scale, that's going to be the amplitude. Now, normally for cosine, it's 1. And that's actually where we begin. So let's start with the yellow graph of cosine. Okay. And what is cosine of 0? Cosine 0? 1. Okay. Pi halves, it drops down to 0. Pi, it goes down to -1, then up to 0, back up to 1. So you've completed 1 complete period there. Back down to 0, down to -1, up to 0, and back to 1 again. Going on the other direction, it drops down to 0, down to -1, up to 0, up to +1, down to 0, down to -1, and up to 0 again. Okay, so this is your basic cosine curve. Try to make it as smooth as possible, hitting most of the points as well as possible. There's your cosine curve. Actually, yellow works pretty good for that. All right. Do we want to do number A in the dark color that we've been using, or you want something else? What do you want? Red? Okay, we'll choose red for A. Okay, now how does this differ from our cosine function? Should have put that in there. Let me go back to yellow for a second. Okay, so the yellow here is y is equal to cosine x. Okay, now we'll go back to red. Red. Okay, how is the red compared to the yellow? What's the difference in y is equal to 1/2 cosine x and y is equal to cosine x? Yes, your amplitude is half of it. So here, where the amplitude should have been 1, I didn't quite hit it, here it's 1/2. Still goes to 0, but it only goes down to -1/2, to 0, to +1/2, to 0, to -1/2, to 0, to +1/2. That's what your amplitude does for you. It's a vertical shrink because A is less than 1. So 0 to -1/2, to 0 to +1/2, to 0 to -1/2, to 0, and on like that. So here is your A function. I don't connect the dots too well. I failed that in kindergarten. Okay, never mind. Okay. So there's the half. You're exactly half of every value. 0, half of 0 is 0. Half of here would be there. Half of here would be there. So half of every value. Okay? What color do you want our B to be? Anybody? Second? Blue, light blue, middle blue. Huh? Light blue. Okay. So the B will be blue. B, blue, alliterative there, right? Where is it going from and to? Yeah, its amplitude is 3. So rather than being 1, it'll be 3. So since cosine usually starts at 1, it'll be 3 times that. So that'll be 3 to 0 to minus 3 to 0 to plus 3 to 0 to minus 3 to 0 to plus 3. Okay? Going in the backward direction, down to 0, down to minus 3, plus 0, plus 3, 0, minus 3, somewhere down. Yuck! What are you doing? Okay. Goodness gracious. Okay. There we go. Down to minus 3, up to 0, and so on. So this one's doing something like this. Always try to keep your curve smooth, not pointed. Okay, I don't do a good job of that most of the time. And try to keep them as even as possible too. There is your 3 cosine x, a vertical stretch. All right? 1/2 cosine x, a vertical shrink. Make sense? So that was your example 2. All right. All right, to delete it. Everybody got it? Anyone still writing? Okay, I'll leave it up as long as you need it. Now, they go through the thing of making a little table. If you want to make a table, make it. I'm not sure I would do it the way they do. I would do a T-chart, probably, a T table, or whatever you call that, because I like T. No. But, however you see it that fits best. To me, popping it on the graph does it for me. That may not do it for you. Everybody got it? Anyone still need that a little longer? Okay. I'll erase all that ink, and now we're going to sketch this one. Okay, I think for the time momentarily, I will go back to here. All right. Going to set up my axes, horizontal and vertical. Now, what do we do about the horizontal axis? What do we think in terms of horizontal axis? The period. Okay? Now, usually a good idea to identify your constants here. Okay, what's your A here? 1. Okay, so amplitude is a normal amplitude for sine, which is 1. What's your B in this case? Second? No, the B is just the numerical part, which is 1/2. Okay, there's your B. Now, What is B related to? A is related to amplitude. What's B related to? Say again? It's the horizontal line. What do we call it? The period. And how is B related to the period? The period is, remember how that goes? 2 pi over B. Our B was and is 2 pi over 1/2, which is the same as 2 pi divided by 1/2, which is the same as 2 pi times 2 over 1, which would be 4 pi. There's your period for this function. Okay? Now what do you do once you've gotten the period? Divide by 4. Divide, that was the division line. Divide by 4. Okay. All right. You divide by 4. So what is, when you divide that by 4, what do you get? Pi. So, my question to you, are we going to want to graph the regular sine function also, or just the sine of pi x over 2? You want to do them both or not? You let me know. Yay or nay? Okay. Yeah, in the book they do them. So the regular function, you want that in yellow again? Okay. So let's do the regular function. The parent function would be y. Ooh, that didn't get to yellow, did it? Okay, that time it did. Y is equal to sine x. Pretty pale, right? Now, what would its period be? Say again? Period for sine or cosine? Period, not amplitude, period. What interval does it repeat itself? 2 pi. And 2 pi divided by 4 is? Pi halves. So since we're going to do that one, let's do the lesser of the two. That one was pi, this is pi halves, so let's do our tick marks for pi halves. Okay, now our amplitude here is 1 on both of these, so we'll just do, and again, don't think that your scales are equal. They're not, okay? I just picked something that's not too cramped. So this is going to be +1 and -1. And we chose to do pi halves, pi, 2 pi, 3 pi, and 4 pi. And negative pi halves. Why is that not shown? There it is. Negative pi, negative 2 pi, negative 3 pi, and out here somewhere is negative 4 pi. Okay. Okay. So let's plot first the sine function. Where does sine begin? At 0. Okay. And it goes up to its maximum at pi halves, down to 0 again, down to the minimum, and then up to 0 again. That's one period. And it follows the pattern. 1, 0, -1, 0. Going backwards, -1, 0, 1, 0, -1, 0, 1, 0. So the sine function looks something like this. Okay, there's your sine function. Yuck, that was supposed to be in yellow, wasn't it? That was one of my best sine curves ever, and I blew it, okay? So let me erase that one, okay? Oh, man. And let's do it in yellow. It'll never come out the same, okay? All right. it was doing something like this, like that, like that, like that, like that, like that, like that, like that. Something like that's not too bad either. Okay, there's our sine function. Now, what color do you want the actual one? Sine pi x over 2. Back to the dark or something else? Help me, help me. Dark? Okay. Now, its quarter periods are your pi's. Well, sine still starts at 0, right? But now its quarter function, it's going up to 1, and it still has the same amplitude, 1, but that's at pi, back to 0 at 2 pi, back to your negative 1 at 3 pi, and then back to 0 at 4 pi. Okay? And that does, by the way, complete one period. One period is 4 pi. Coming this way, minus pi, 2 pi, minus 3 pi, and minus 4 pi. So here is your, okay, there is your sine of pi over 2. A horizontal stretch. We took the accordion that was the yellow function here, the sine function, and doubled it, stretched it twice as far. So now everything moved twice as far away from it was. Here it was at pi halves, this one's at pi. This one was at pi, it's now at 2 pi. Oh wait. Yeah. This intersection here was at pi, it's now at 2 pi. Okay? This one was at 3/4 pi, now it's at 3/8 halves pi. So everything is doubled. This was at pi, I'm sorry. This was at 2 pi, now it's 4 pi. Okay, we don't see the rest of it. So you see that's the horizontal stretch. To me, having the parent function isn't as helpful here, but you do see what's going on. Does that make sense? Does it make sense? All right, good deal. So that was example 3. Let's see how they did it. So let's clear my scratch out of the way and see how they did. The amplitude is 1, first thing we noted. Moreover, B is 1/2, second thing we noted. Note what A is first, tells you what the amplitude is. Note what B is, it lets you calculate the period exactly like we did, 2 pi over B, 2 pi over 1/2, that comes out being 4 pi. They didn't show how they got it, but it's 4 pi. Then you take that interval, divide it into 4 equal parts. Pi, 2 pi, 3 pi, and 4 pi. Those are our key points. 0, pi, 2 pi, 3 pi, and 4 pi. Okay? And they do this little table this way. That's perfectly fine. I like to just do it on the graph. It makes more sense there to me than it does right like this. The sine starts at 0, and at 1/4 of the period, it goes up to 1. At half the period, it's back to 0. 3/4 of the period, it's -1. Full period, it's back to 0. Okay? So they like to do it that way. And here's what the graph is. Now they show what we did in yellow, they're doing in gray. And you see this as a regular sine function there, period of 2 pi. However, when they do pi over 2, we stretched it, so now the period is 4 pi. Pi, 2 pi, 3 pi. Okay? Does that make sense? Yay or nay? Okay. So that is example 3. Now we're moving to translations of sine and cosine curves. If you remember, and I'll tell you right now, I'm going to modify this because I like to do it my way, the book does it its way, okay? They're adding a constant c in, or actually subtracting a constant c. I don't like to do it this way, and there's a reason for that. My background is more physics, less math. Maybe the mathematicians like it this way. I don't. Okay? It comes out the same, but I'll show you how I like to do it. If this is what you're given, y is equal to a sine bx minus c, or y is equal to a sine bx, the cosine bx minus c. What does the a refer to? Amplitude. What's the b help you find? Period. Now, what the c is doing is being subtracted from the x, and that's why I don't like the way they do it here. That's going to be a horizontal shift. And if that's a minus sign, which way is it shifting? No? Okay. Yeah, to the right. Remember, anything to do with the x is always backwards. So it shifts to the right. A plus c would be shifting to the left. Strange. It's a horizontal shift or a translation, okay, of either the sine or the cosine curves. So comparing that with a y is equal to a sine bx, or y is equal to a sine bx minus c, you'll find that the graph of the first one, of the second one, completes one cycle when this goes from bx minus c goes from 0 to bx minus c to 2 pi. That's a period. Whatever follows a sine is going from 0 to 2 pi. Then you have to solve this for x. What you do is add c to both sides, divide by b. So that's just going to be 0. Add c to both sides and divide by b. Well, over b, that's your period. Your c over b, that's what we call a phase shift, a horizontal shift. And I don't like doing it. I mean, what I do does the same thing, but I do it up front, okay? In my mind, the better way to write this is a sine, factor out the b here, and leave you x minus c over b, okay? If you do that, this is obviously still affects the period. This is your phase shift, c over b. So why even mess with the b inside, pull the b outside, and that automatically gives you your phase shift without having to do all this every time. Okay? Same thing with cosine. Factor out the b, get it out front, and that gives you how much x is being shifted, right or left. If it's a minus, it's to the right, plus to the left. They do it this way, which is, to me, harder, but if you see it better, use their way. Okay? So then solving for x, you get x on the left-hand side, when that thing was 0, this is now c over b, and it goes to the other side of c over b plus 2 pi over b. Well, that's one period later. Okay? So here's first endpoint, and the second endpoint is one period past. Okay? And here's doctrine. Okay. So that number, c over b, is called the phase shift. You can also call it the horizontal shift. Okay. Later, when we get into applications of it, and you're talking about waves, things like this, that's where the term phase comes from, is the shift of the phase of the wave. So that's why it's called the phase shift. All right, so graphs of sine and cosine functions. Now we've got 3 letters in here. A refers to amplitude, B affects the period, C deals with a phase shift, a horizontal shift. That's actually C over B, and if you just factor the B out, it would be obviously C over B. Okay? Now, we always assume B is positive. A can be positive or negative. C can be positive or negative. B, we always assume to be positive. Okay? Not even 0. The left and right endpoints of one cycle of the graph can be determined by solving these equations. Whatever falls in here, solve it for 0, solve it for 2 pi. That gives you the left and right endpoints. That's one way to do it. It's perfectly fine. But if you recognize C over B as your phase shift, you start there and then do your period from there. It does the same thing. You know, it will literally, you know, wind up with the same result. Okay? So here's one. This is, it's not in the book, is it? Okay. Oh, that's example 5. Yes, they skipped 4. So let's do 4 first. Okay? I don't know why they're... Sometimes they skip the hard ones. Yeah, they do the simple ones and skip the hard ones, and that I don't really care for. But then when they skip the easy ones and jump right into the deep stuff, I say, well, you really need to do both of them, all of them. But, you know, I'll do them all. So here is example 4. Analyze the graph of y is equal to 1/2 sine of x minus pi thirds. Okay. Now, when you're doing this, I suggest identify your constants, your parameters. What are the parameters we deal with so far? A is equal to 1/2. B is equal to 1. Okay? And I like to call it C. They call it C over B. In this case, it's either one of them. C is equal to, second, pi thirds. That's your phase shift. That's where you go to start. Okay? Now, A is related to what? You said it. A is related to the amplitude. Is exactly, in this case, equal to the amplitude. So this is the amplitude. Okay? Is 1/2. B is related to what? Period. How is it related to the period? Period is 2 pi over B. And B in this case is 1. So your period is 2 pi. Okay? And C is your phase shift. Okay? Now what do we do with the period? Divide it by 4. Okay? And what is 2 pi divided by 4? Pi halves. Okay. Now, okay, I was going to ask if you want me to plot the sign on here first or not. I don't really see a purpose in it, but if you like to see it, I'll be glad to do it. Not? Okay. Now, the period, the amplitude, let's go on and deal with that. That's as high or as low as the function's going to go. It's going to go up to, I think I will change this a little bit. Okay, I'll put the top up here to be 1 and the bottom down here to be -1, but we're not going there. We're going to plus 1/2, minus 1/2. That's as high or as low as we're going to go. That's our amplitude. Okay, so going to deal with the vertical axis with the amplitude. Okay, get that set. All right, now horizontally, we need to start with that phase shift. Okay? Now, you already told me the period divided by 4 is equal to pi halves. Okay? So you're going to need to tick off pi halves, but we also have a phase shift of pi thirds. So you got to have the least common denominator between those, and what is that going to be? Pi 6. So that's going to be how we're going to tick off, is in 6 of pi. So that's going to be okay, pi 6, pi thirds, pi halves. 1, 2, 3, 4, 5, 6. Pi. 1, 2, 3. This is 3 pi over 2. Okay? Minus pi 6, minus pi thirds, minus pi halves, minus pi, minus 3 halves pi. Okay. It's awkward because they've not got the same denominator, so we have to account for it. So we're going to start at the phase shift pi thirds. That's where it starts. What is sine at the beginning? Where does sine begin? Usually. At 0. Okay? And usually that's at origin. It's not now. We start at the phase shift. So that's where the sine is going to start now at 0 right there. Okay? Now from there, we have to tick off our quarter periods. And the quarter period is 1/2, pi halves. Well, in 6 of a pi, that's 3/6 of a pi. So we do 1, 2, 3, and you go up to your amplitude. Another 1, 2, 3, and you're back down at 0. And a 1, 2, 3, this one you would be down here at minus pi halves. Okay? And going backwards, 1, 2, 3, that's pi halves. 1, 2, 3, 6 of a pi is pi halves. You're down to minus 1/2. 1, 2, 3, you're at 0 again. 1, 2, 3, you're at positive 1/2. 1, 2, 3, you're back at 0 again. So here's what your function looks like. Whoops. Okay. Had to mess that up. Okay. Now, let's review what we did here. You determine the amplitude, what the A was, that told you your amplitude, 1/2, and that's what you're going to scale your y-axis to. All right. We had a combination of things here. Your starting point, your phase shift, pi thirds, but your B was 1, so your period is 2 pi. A quarter of 2 pi is pi halves, so that's got to be your interval. But you've got to have your pi thirds on there too, so we had to do it in terms of pi 6, so you could get your half pi's and your third pi's in there, okay? I'm keeping hungry thinking of half pi's and third pi's, okay? So you start at pi thirds, and the sign usually starts at 0, and then you go pi halves, a quarter of your period. That's 1, 2, 3/6 of a pi. That's pi halves. That's your plus 1. 1, 2, 3/6 of your pi is 0. 1, 2, 3/6 of your pi is negative. And from here, we also do backwards. 1, 2, 3. That's down to. Ooh, I put that in the wrong place. I thought something looked bad here. That means I'm going to have to erase a bunch. Okay. Okay. I didn't have those in there too well in the first place. So let me see if I can get that again. 1, 2, 3. So this is down here at minus pi, minus 1/2. 1, 2, 3. Oh, I got the rest of them right then, maybe. That's that 0, 1, 2, 3 was plus 1/2. 1, 2, 3 was 0 again. Okay. So it's something like that. Okay. Because the horizontal scale you go by pi halves, but you're starting from pi thirds, so that's why I had down 6 of a pi. 1, 2, 3 was minus 1/2. 1, 2, 3 was was 0 again. 1, 2, 3 was plus 1/2. 1, 2, 3 was 0 again. So there is your sine curve. Horizontal shift 1/3 to the right. That's what that tells you. Period 2 pi, just like our regular one. Let your amplitude 1/2. The vertical shrink. Do you see how to do it? Okay. That was example 4. All right, to erase this. Everybody got it? So let's do example 5. This is example 5. Where would you begin? Say again? I can't hear.
List the constants.
Yes, list the constants. Very good. And what's the first one? Okay, well, A is equal to -3. So what does that tell you the amplitude is? 3, absolute value of that. Okay, next. B is equal to 2 pi. Okay, what does that tell you something about? The period is what? Okay, 2 pi over B, and B is 2 pi, so the period is 1. Now, this is not what the book does, but this is what I do. I like to factor that out and make that 2 pi times x plus if you factor out the 2 pi, what do you have left? Factor out 2 pi and you got, factor the 2 pi out of both of those terms. Took it out of the x, now take it out. Left with what? You're left with 2, aren't you? You're factoring it out, dividing it out. Dividing out the 2 pi there, 2 pi into that would just leave 2 times. Right? So your phase shift is what? -2. Remember, anything following the x is backwards. So the phase shift is -2. Okay? The period is 1, and the phase shift is -2. So the phase shift is -2. Now, what do we do with the period? Divide by 4. So what's your interval then? 1/4. Okay. I think we have everything we need to do our graphing. Okay? So I'm going to do the vertical graph here, horizontal scale there. Okay? Vertical, I know I'm going to need at least 3 up and down. 1, 2, 3, 1, 2, 3. Okay? This will be 1, 2, 3, -1, -2, -3. Gonna need those. Now, the interval is 1/4. Your phase shift is -2. We can get all that on with no problem. So let's do our quarters. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this will be 1/4, 1/2, 1, 2, -1/4, -1/2, -1, -2. Okay. Where's my phase shift? -2, way over here. We're dealing with a cosine function. Where does cosine normally begin? At 1. But our coefficient is -3. So it's going to start at -3. So this is where we began down here. Normally starts at 1, but we have the coefficient for the cosine is -3, so it's going to start here at -3. Okay? Now, what we're going to do at every interval, which is 1/4, we're going back up. So it goes up to 0, up to +3, back down to 0, back down to -3, back up to 0, back up to +3, back down to 0, back down to -3, back up to 0, back up to 3, back down to 0, back down to -3, back up to 0, back up to 3, back down to 0, and down to -3, back up to 0. I think that's enough. Okay, oh, let's go in this direction. Got most of them, but not all. So let's go backwards, and this will go to 0 here. All right, so it's doing something like this. Finding my points here is going to be hard. Okay, there we have it. Mine's not spaced too well. Figured that. But the amplitude is 3, so it's going from +3 to -3, but it's beginning at the -3. The phase shift tells you where to begin horizontally. The cosine normally would begin at 1, multiply that by -3, that's where you begin down here. Now, one thing to notice, your phase shift is -2, well, and your period is 1, so 1 over from that, you're going to start it again, and 1 over from that, you start again. So this is just as if it was -3 without the phase shift in it. You would start at the same place and go in the same direction. But that's how we began, and that's how you proceed. Okay, does that make sense? Okay? Yes, hey.
May I make an announcement?
Surely.
We have our volunteer fair and get on board day going on down in the faculty lounge. It's an opportunity for you to view the organizations, both on campus in the community and in the community that you can sign up to volunteer with. So if you guys come down, check it out. It'll be over with at 12.
Okay. Now, someone was in this class and participating. They said it started today 10 to 2 on Birmingham, and tomorrow 10 to 2 here. Has that been changed?
It was yesterday.
Oh, yesterday.
11 to 2 on Birmingham yesterday. Today is 10 until 12.
Today.
But it is short because of the installation in Birmingham.
Oh, okay.
Yes, sir.
Okay. So it's today, and as soon as you get out of class, you can go down, faculty, staff down here.
Yes, sir.
Right next to the cafeteria. All right, good deal. Thank you. I'm supposed to know her. Does anyone know who she is? Huh? None of you. There y'all. Oh, she does with SGA. Is she normally on Birmingham or here? Huh? You think here? Okay. Huh? Oh, in the rec room. Oh, okay. Is she a student or a faculty? A staff? Oh, she's a student. Huh? Or she's staff? Okay. All right. I thought she was, but okay. Good deal. So let's see quickly how they did it and see if we messed it up any. Okay? Let me erase the ink. And let's see. The amplitude 3, yes. The period is 1, yes. The solving the equation, oh yeah, they do it that way. All right, you see that the interval -2, -1 corresponds to 1 cycle. Yeah, we found that out too. We didn't do it their way. And look at this. That's pretty much what we did. -2 went up, and what they didn't do was 1/4 of 1. 1/4 was your interval. So that's 1/4, 1/2, 3/4, 1, all the way back here. Starting down here, went up to 0, up to +3, down to 0, down to -3. And then you just keep the process. It's exactly what we got. Not quite as pretty as ours, but close enough. Okay? Any questions on that? All right, we'll begin next time with, they don't do, yeah, it's the final type, so this is on the page right there. I can't see my last. Okay. We'll begin there next time. Homework exercises. We came close to finishing. Do any of the odds 5 through 17? Any of the odds 19 to 27? I'm sorry, 19 to 29? Any of the odds 31 to 37? Any of the odds 39 through 59? Any of the odds 61 through 65? And you can do 67, but I would stop there. Okay? We'll pick up the rest of them next time. All right, any questions? Okay. We'll pick up and go from there on Thursday. Okay? Try to get your test in the next week or so. We want them in before we hit the end of this chapter and you have your second test. So try to get them in within the week if you can. If you need more time, you can have it, but try to get them in within a week. Good deal. Any questions?